Transportation problems we solve in two phases. First phase is known as initial basic feasible solution. For getting initial basic feasible solution, we use three methods. First one is NWCM, which is known as north-west corner method. Second method is LCM, which is known as least cost method. It is also known as matrix minima method. And third one is VAM, which stands for Vogel's approximation method. So to get the initial basic feasible solution, we use three methods. Most appropriate method is VAM, Vogel's approximation method, to get initial basic feasible solution. After getting initial basic feasible solution, we go for getting optimal solution. And here in optimal solution, we use MODI, that is modified distribution method. So today, with the help of one problem, we will see how we get initial basic feasible solution, and after that we will use MODI method to find optimal solution. So this is a problem related to transportation, and we will see here it is given in the question. There are three factories and four warehouses. Unit transportation cost matrix is given below. Capacities at factories and demand at warehouses is also given. We have to find optimum solution. So first, for this problem, we will go for finding initial basic feasible solution with VAM method, and after that, after getting the initial basic feasible solution, we will use MODI method to find optimum solution. Here factory and warehouses, factory F1, F2, F3, then warehouse W1, W2, W3 and W4, then capacity is given, and here demand is given. Before starting to solve the problem, we check the problem is which kind of, that is maximization or minimization, balanced or unbalanced, or restricted or unrestricted. So here in this case, the costs are given in the matrix. So whenever the cost or time is given, so we should consider the problem is related to minimization. And for getting initial basic feasible solution, we have to bring the problem, if it is of maximization, we will have to bring it in minimization. Before proceeding to solve the transportation problem and to get initial basic feasible solution, we will have to go for certain checks. We will see the problem should be minimized, problem should be balanced, and problem should be unrestricted. So here we will check that the matrix figure is given related to the cost. So if the figures given in the matrix related to cost, time, which we want to minimize, so the problem will be minimization. Otherwise, if it would be maximization, we will have to convert it into minimization. Then we will check whether problem is restricted or unrestricted. We will have to bring this problem into unrestricted, and problem should be balanced. How we will check? We will check the demand and capacity. Capacity means supply. So this should be equal. If not, we will have to add dummy row or column as per our requirement. So here we will check here 5 and 8, 13, 13 and 7. Here we will check 5, 8, 13 plus 7, 20 and 15, 35. So total demand is of 35 and supply or capacity is given 9 and 7, 16, 16 and 18, 34. So here capacity or supply is 34. So this is not a balance problem because demand and supply is not equal. So we will have to add here a dummy row with F4 factory having the zero cost, and here we will add one supply. So in this way we can balance this unbalanced problem. W1, W2, W3, W4 and supply or capacity. So I am writing here supply, here F1, F2, F3 and F4. F4 is dummy one, dummy, dummy. 10, 70, 40, here 30, 38, then 50, 40, 70, 10, 60, 20. Here for F4 dummy the unit would be 0, 0, 0 and 0. Here demand is demand in terms of unit 5, then 8, then 7 and 15. So total of this is 35. It should also be 35, 7, 9, 18, and here you will have to add to equalize this demand with the supply, and for what amount it is getting shortage you will have to add that unit, and I am adding here 1 for F4, that is dummy factory, where costs are given 0, 0, 0, unit are given 0, 0, and here 1 I have added to balance this problem. Solve this problem with the help of VAM method, and in VAM method we first calculate penalty for each row and each column. So first we will try to find the penalty for each row and then penalty for each column. Here penalty. So for finding penalty for row we will take two list numbers for each row. We will see. So here see 10, 30, 50 and 10. So there are two list numbers 10 and 10. So 10 minus 10. We will take difference of two list numbers. So 10 minus 10, that is 0. Then here two list number 30 and 40. So here difference would be 10. Then here the two list number, our F3 row we will see two list number 20 and 8. So difference would be 12. and here 0 0 is two list numbers, so this should be 0 minus 0 0. Like this we will go for calculation of penalty for each column. Penalty, so here 10, 70, 40 and 0. So two list number would be 0 and 10. So here 10 would be the penalty for column 1. Here two list number 8 and 0, 8 and 0. So 8 would be the penalty. Here 50, 40, 70, 0. So 40 and 0. So here penalty would be 40 and 10, 60, 20, 0. So two list number 10 and 0, that is 10. So here we will identify the row or column with highest penalty. See here 0, 10, 12, 0 and 10, 8, 4, 40 and 10. So highest penalty is 40. What we are seeing, highest penalty is 40. So here we have to identify the column or row with highest penalty, and the column what we are getting here, W3 column, where the highest penalty is here. In this column we will find that which cell have the least cost or smallest unit cost. So see here 50, 40, 70 and 0. So here 0 is the least cost. 0 is the least cost, and here how much quantity we can allocate in this cell, here in this cell. So with the 0 cost, see here demand is of 7 but supply is of 1. So maximum how much quantity we can allocate here, 1 unit we can allocate here, maximum 1 unit we can allocate 1 unit, and here we will cancel, remaining is 0. So this F4 row is exhausted, and here 7, now remaining would be 6. Now again we will go for calculation of penalty for each row and column, and here in this case what will happen, that this row is exhausted. So what I'll do, I'll just cut this line, because this row whatever the supply is exhausted, so I'll cut like this. Now the penalty for this F1 will remain same, penalty for F2 will remain same, penalty for F3 will remain same, right? There may be chances of changes in penalty because one row is cancelled here, so there is chances that penalty of columns may be differ. We will check what would be the penalty. So we will calculate penalty for each column. So here see, the remaining elements are 10, 40. Two list elements here is 10 and 40. So here the difference between this is 40 minus 10, that is 30. Then here two list is 8 and 30. So difference would be 22. And here the two list is 50 and 40. So difference would be 10. Here list is 20 and 10. Two list. So here 10. So we will check that what is the highest penalty. So here 0, 10, 12. And here in the column 30, 22, 10 and 10. So highest penalty is 30. See here, highest penalty is 30. So here in the column 1 we will check the least cost. So least cost is 10 here. Least cost is 10. And how much unit we can allocate here? Here maximum supply is 7 and demand is 5. So demand is 5, so we can allocate here 5. We can allocate here 5 unit. 5 unit. And this 5 will be exhausted, remaining will be 0. And here also remaining will be 2. And in this way this W1 column is exhausted. This column is exhausted. We will just cut it down. Now again we will go for calculation of penalty for each row and column. So here right now we have cut one column. So this penalty will remain same. 22, 10 and 10 will remain same. There may be chances of changes in the penalty of rows. So here the two list, I am calculating another penalty here besides this. See here the two list 30, 50 and 10. Two list costs are here 10 and 30. So differences will be 20. Then 30 and 40, out of these three, 30, 40, 60, two list costs are 30, 40 and difference of this will be 10. Again here the two list cost 20 and 8. So difference would be 12. And this will remain same. You can check 30 minus 8, 22. Then two list 50, 40, 10 and here 20 and 10, 10. So we will consider this one for this. So 22, 10 and 10 and 20, 10 and 12. Out of this we will choose the highest penalty. So this one is the highest penalty. This one is the highest penalty. Here we will check that which cell having the least cost. So we are seeing this cell F3W2 is having the least cost. So here we how much unit we can allocate. So here 8, demand is 8 and supply is of 18. So we can allocate here direct 8, 8 unit, 8 unit and this will exhausted, remaining 0 and here 8 unit, so remaining would be 10. So right now this column second is exhausted. Column second is exhausted. Now we will check of the penalty, and here the difference will calculate another penalty, because one row uh, we will go for calculation of penalty, because one column has been strike out here, and again we will calculate. This will remain same. You can check here 50 40 difference and 70. So list cost is 50 40, so difference would be 10. Then 10 and 20 list cost, here two list cost, difference would be 10. Now we will calculate for row. So 50 and 10, these only two are left, so 50 and 10, difference would be 40. 60 and 40, difference would be 20. 70 and 20, difference would be 50. So now we will consider this penalty 40 20 50, 10 and 10. So out of this, the highest one we will take. Highest one is 50. This one is the highest one, 50. And here we will check the list cost. List cost is 20. So here we can accommodate maximum 10 quantity. So we will give here 10 quantity, right? And this is exhausted, remaining 0. Here total 15 demand, so 10 minus 15 minus 10, it would be 5 remaining. So in this way, here this row will be cancelled out because it is exhausted. Now we will calculate again the penalty for each row and column. So here see 50 and 10. So the penalty would be 40. 50 minus 10. 40 and 60, penalty would be 20. Difference of 60 and 40, 20. So this will remain same, because we have a strike out this row. Now we will calculate for column. So 50 and 40, this is 10. 60 and 10, 60 and 10, difference would be, so here we will have to calculate fresh penalty, and here we will see for column third and fourth. So 50 and 40, only two, so fresh penalty would be 10, and 60 and 10, fresh penalty will be 50. So here out of this 10, 50, 40 and 20, the maximum penalty is 50. So here we will check the least cost remaining. Here is 10. Out of this two, 10 is the least cost. We will try to allocate the unit here. So maximum unit we can allocate here is 2, because 2 is remaining here. So we will allocate here 2 quantity, and this will be exhausted, means F1 row will be exhausted. F1 row will be exhausted, and here 5 minus 2, so remaining would be 3. 3 unit is still remaining, so we will allocate 3 unit here, because only these two cells are left. Other row and column has been striked out, so we can allocate here maximum, here 3 and here 9. So maximum we can allocate here 3 unit, right? So this column is also exhausted. This column 4 is also exhausted, so we will cut here. Now here after allocation of 3 unit here, so this will remaining 6 unit, and this 6 unit here also 6 unit remaining, for only this cell is remaining and 6 unit is remaining, right? So we will allocate 6 unit here, 6 unit here. So in this way we have allocated the different supply and demand quantity and unit to the different cells to find the initial basic feasible solution. Now we try to find here that whether the problem is feasible or not. Have we got initial basic feasible solution? For this, we find that how many occupied cells are there. So see here occupied cells 1, 2, 3, 4, 5, 6 and 7. So there are 7 occupied cells, and this should be equal to m plus n minus 1 equal to number of occupied cells. Here we have number of occupied cells equal to, see here, count 1, 2, 3, 4, 5, 6, 7. So number of occupied cells 7. And here number of m means total number of rows. So total number of rows 1, 2, 3, 4. Total number of row 4 plus total number of column. N denotes total number of column. So total number of column 4 minus 1. So this will be 8 minus 1 equal to 7. So here we are getting 7 equal to 7. If this condition satisfies, means this is initial basic feasible solution. So how we find that the problem has the initial basic feasible solution? If m plus n minus 1 equal to number of occupied cells. If it is equal, so this would be the initial basic feasible solution. Now from here we can proceed for getting the optimal solution. So we will see how we get optimal solution with the help of Modi method. And so this is the table or matrix we got in the initial basic feasible solution, and this table shows the allocations of the different units or occupied cells. The green mark shows the occupied cells. With the help of occupied cells, considering the occupied cells, we will go for calculation of row number and column number. Here we will select that row or column which is having the maximum occupancy, which is having the maximum occupied cell. So see here, 2 occupied cells, 2 occupied cell, 2 occupied cells, 1 occupied cells. Here we will go in this row 1 occupied cell, in row 2 1 occupied cell, in row 3 2 occupied cell, and row 4 we are getting 3 occupied cells. So for this we will assume V equal to, means column number, V indicates column number, and V4 we will write V4 V4 equal to 0. V4 equal to 0. And with the help of this, we will proceed to calculate the row number and column number for each row and column. So here we can take any of we can calculate the U1, U2 and U3. Like this we will write V1, V2 and V3. Now we will calculate with the help of, we have the value V4, and how we calculate, see, we will take C equal to U plus V. We use this formula, C equal to U plus V. C equal to U plus V. So here C means we will consider all the occupied cells. Only for that we will use. So see here that occupied cell we are considering this one. We have this. We have the value of V4 equal to 0. So that's why I am taking this occupied cell, so that we can have the value of U1. So here the value of C, we will take this value, this 10 equal to U, we have to calculate, plus V 0. So U equal to 10. So here I will write here that the value of U 10. Like this I'll calculate for other row. Just like we can go for this, as we know that the value of C equal to U plus V. So here the value of C 60. So I'll take 60 equal to the value of U, we have to calculate, and we know the value of V is 0. So I'll write here 0. So U equal to the value of U will be 60. The value of U will be 60. Like this we can go for calculation of the value of U3 also. Here we know V4 equal to 0. So C equal to U plus V. C here I will take 20. 20 equal to U, we have to calculate, means U3 we have to calculate, plus V4, we have V4. So here at the place V4 you will write 0 plus U3 we have to calculate equal to 20. So here U3 20. Like this we have calculated the row number for each row number. Now we can go for calculation of V1. See here how you, because this one is the occupied cell here. So here we can take this 10 equal to, at the place of C we can take 10 equal to, at the value of U1 plus V1. U1 plus V1. So 10 equal to U1. U1 is 10 plus V1. So this 10 will go here, we will get V1 equal to 0. V1 equal to 0. 10 minus 10, V1 equal to 0. Like this we will go for calculation of V2, and here in case of V2, see here we will take 8, C equal to 8, and the value of U3 plus V2. See here, 8 equal to U3 plus V2. So we will have the value. How we can calculate? I will show you. 8 equal to U3, that is 20, plus V2. So here 20 will go here, it will be minus. So V2 equal to 8 minus 20. So we will have the value of V2 equal to minus 12. Here the value of V will become minus 12. Like this we can calculate the value of V3. We can take this cell to calculate, because here C equal to 40. C equal to 40. We'll take U2 plus V3. So 40 equal to, at the place of U2 we will keep 60 plus V3. So V3 equal to 60 will go this side. So it will become minus 20. So here the value of V3 is minus 20. Like this we go for calculation of row number and column number. We will calculate this row is also, and we will consider here U4 equal to, we can consider this cell, we will consider this cell, and here the C, the value of C is 0, equal to, we will take U4 and plus V3. So 0 equal to U4 we have to calculate, plus V3 minus 20. So when minus 20 will come this side, it will become plus 20. So U4 will become plus 20. So this is 20. So like this we have calculated the row number and column number for each row and column. Now we will calculate the opportunity cost for each unoccupied cell. Unoccupied cell means this cell, for this cell, for this cell, this cell, where there is no any allocations. So we will calculate the opportunity cost for each unoccupied cell. With the formula, we have the formula for calculation, that is opportunity cost equal to, we denote opportunity cost with this triangle. Opportunity cost equal to C minus U plus V. C minus U plus V. This formula we use, C minus U plus V. For example, I am taking to calculate the opportunity cost for this cell, right? This unoccupied cell. So here the value of, means for this cell F1W2, 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 C is 30. See here, C is 30. C is 30, and we have the value of U. We have the value of, we will take here U1 and this V2 for this cell. V2 and U1. So we will take U1 plus V2. U1 plus V2, and we will find here 30 minus the value of U1 is 10 plus the value of V2 is minus 12. The value of V2 is minus 12. Minus 12. So here after solving we will get 30 minus 12 and 10. So this would be minus 2. So minus it become plus. 30 minus plus, so 30 plus 2 equal to 32. So here the opportunity cost I am marking with red. Opportunity cost will become 32 for this cell. Like this I will calculate opportunity cost for this cell, that is F1W3. F1W3 means this one, F1W3 50 equal to C minus U1 plus, I'll take V3 and here the value of C is 50 minus the value of U1 is 10 and the value of V3 is minus 20. Minus, so this will be plus minus 20 minus 20. 50 minus 10 minus 20, that it will become minus 10. So minus this will be 60. So here I'll write opportunity cost 60. Opportunity cost 60. Like this I'll calculate the opportunity cost for this cell. So this would be 70 minus 60 plus 0. So here it will be 10. For this 30 minus 60 minus 12. So 60 minus 12, this would be 48, and 30 minus 48. 30 minus 48, it would be minus 18. So here there is no any cell with unallocated. Here we are coming here 40. So 40 minus U3, we will take U3 20 and here V1 0. So 40 minus 20, here V1 is 0. So U3 plus V1. So it will be 20. So 40 minus 20, here it would be 20. Again for this cell 70 and minus 70 minus under bracket 20 minus 12. So 20 minus 12, 8, and sorry, 20 minus 20. We'll go for calculation of opportunity cost for this cell, that is F3 and W3. Here 70 minus 20 minus 20. 20 minus 20, 0, and this will be 70. 70 minus 0, 70. So here we will write 70. So there is no any. Here we have left here 0 and minus 0 minus 20, 0. So here we will have the opportunity cost minus 20. Here we have the opportunity cost 0 minus 20 and minus 12. So this would be minus 20 minus 12 minus 20 minus 12, that is 8. So 0 minus 8. So here 0 minus and 20 minus 12. So 20 minus 12 equal to 8. So 0 minus 8 equal to minus 8. And one cell is remaining unoccupied. So this would be 0 minus 20 and here v 0. So this would be minus 20. So in this way we have calculated the opportunity cost for each unoccupied cell, which denotes the figures written in the red color, and the figures written in green color, that is the allocated cells, or you can say occupied cell. So the next step is to find whether the all opportunity costs are positive or negative. So see here we have certain opportunity costs are negative. Here minus 20, minus 18, minus 8 and minus 20. So if the opportunity costs are negative, solution is not optimal. We need to have these all opportunity costs should be positive. If we will get all opportunity costs positive, the solution would be optimal. So here what we are getting, that some of the opportunity costs are negative. We will have to go for the improvement. And how we will go for improvement, we will see. We have to select the unoccupied cell with highest negative opportunity cost. We have to select here the highest negative opportunity cost. So see here what we are seeing, that there are two highest negative cells, that is equal, minus 20 and minus. So here in this case, that minus 20 and minus 20 we are finding at two places. So here we will check, we will select that unoccupied cell with highest negative opportunity cost, and here we are getting at highest negative opportunity cost at two places. If there are more than one such cells, then select the cell where more units can be shifted. So in this case, I'll take here that we will select this minus 20 and proceed with this for improvement. We will have to draw horizontal and vertical line, and we will have to make a loop with the help of vertical and horizontal line, and trace a closed path using most direct route through at least 3 occupied cells and then back to the unoccupied cells. So, drawing horizontal and vertical line, I'll start from here like this. We'll take turn from the occupied cell. We'll take turn from the occupied cell. The next turn like this, and again this one. So this is a loop, closed loop. Now we will start putting plus and minus sign. So I'll start from here, plus, minus, plus and minus here. Now from the plus and minus sign cell, we'll select the negative sign cell, that is this one and this one. So among these two, we will find that which is the least occupancy. So here we will see 1 is the least. We will shift 1. We will add 1 where the positive sign in the cell, and we will deduct from the cost where it is negative sign. So I'll shift here. I'll shift here 1 first, positive. I'll deduct 1, so it will become 0. It will become 0. I'll add here, so it will become 7. Deduct here, it will become 2. It will become 2. This will remain as it is. So see here, what I did, I added 1 here because from this 2 negative sign cell, I have selected the least cost cell, least cost. So from this 2 negative sign cell, I have taken here, and we have to take here the least cost. So least cost among these is here, see 1 and 3. So among this I'll select this one, 1. So I have added here 1. When I will deduct from, because here minus, I'll deduct, it will become 0. You have not write anything here, there would not be allocations. Then here I'll add at this, at the place where positive sign we have to add. So 6 plus 1, 7, it becomes 7. And here from 3 I'll deduct, because here negative sign, so I'll deduct 1 from 3, so it will become 2. So there will be fresh table I'll make. So like this we got the fresh allocation, and here we will again go for calculation of row number and column number, and then we will go for calculation of opportunity cost for each unoccupied cell. here we will take u1, u2, u3, u4, then v1, v2, v3, v4. As we are seeing here again that number of occupied cells are more in column number 4. So here we will assume it as column number 0, and with the help of this we will calculate the other row and column number. So we can take as usual as we have done previously in the same problem. So here we can take, see here, with the help of occupied cells, uh, as we know, calculation method of C equal to U plus V. This is the formula we use. So here see here, C equal to 10. C equal to 10 for this U1. We are calculating U1. So C equal to 10. V is 4. V4 equal to 0. C equal to 10. V4 0. So here U1 plus V4. So value of V4 is 0 plus U1, C equal to 10. So U1 will become U1 equal to 10. Like this we will calculate for each row and column. So U1 equal to 10. Here see V4 0, U2 we will calculate and U2 will become 60. Here cost is given 60. Like this we will calculate for this because we consider only occupied cells. So here U3 we will calculate V4, the value of V4 is 0. So this will become also 20, and here U4 will become 1. So from this we'll calculate, we'll use this cell. This is occupied one. So here U1, value of U1 is 10, and this will become 0. That is C equal to 10 equal to U1 plus V1. So V1 will become 0. Like this we will consider this one. The U3 is 20, C equal to 8 and V2. So we will get minus 12. So to calculate V3 we will use this cell. So 40 here, U2 value is 60, and we can get V3 value, that is minus 20. So in this way we have calculated the row number, and now we will go for calculation of opportunity cost for each unoccupied cells. Like this one is unoccupied, this one is unoccupied, then this cell, this cell, this cell, this cell, this. We will go for calculation of opportunity cost, and we know the formula, that is, this one is the formula, C minus under bracket U plus V. With the help of this formula we will use this 30 here, minus 12 and 10 we will use. So 30 minus U1 10 and minus 12. So U1 minus U1 10 minus V2 minus 12. So this will become minus 2, and 30 minus 2, that is 30 minus 2, it will become 32. I am writing here 32. So like this, here we will calculate for 50. Here u1 value is 10 and this minus 20. v3 value is minus 20. So here 50 minus under bracket 10 minus 20. So it would be minus 10 and 50 minus 10. So this will become 60. So like this we will calculate opportunity cost for this one, and for this when you will use this formula you will get 10. For this you will get minus 18. Now here 20, 70. For this it would be 0, 12, 20. So in this way we calculated the opportunity cost for each cell, each unoccupied cell. And here what we are finding, that there are certain cells where we are getting the negative opportunity cost, like this one only is the negative opportunity cost, remaining others are positive. So we will have to go for the improvement. Now there is only one negative opportunity cost, that is minus 18 in this cell F2W2, and we will proceed for making a loop with the help of vertical and horizontal line. And here and in this way we have completed the loop. Now we will find that we will go for giving the positive and negative sign. So we will start positive and negative sign from this cell, positive, then negative. At every turn we will give negative and positive sign, here positive and here negative. Now we will select the negative sign cell. So negative sign cell is this one, and here the list allocation is 2 in this cell. So what we will do, we will add in the cell where positive sign, and we will deduct from the cell where it is negative sign. So here we will add 2 here, Then here we will deduct 2 and it will become 0. We don't write here. Here we will add, so this will become 12. 10 plus 2, 12. Again we will deduct 2, so this will become 6. Now I'll make a fresh matrix where I'll show this new allocations. So here we have done with the second improvement, and I have made the fresh matrix wherein allocated I have shifted after completion of the loop. Now again we will go for calculation of row number and column number. So here row number and here column number and u1 equal to u2 equal to u3 equal to u4 equal to v1 equal to v2 v3 v4. Here the maximum number of occupied cell is in w4, so I'll take it as 0, and then we'll calculate how we have calculated previously. Here for example v4 I'll calculate here, so u1 will become 10. This will be no here, because we can go for calculation, we can't calculate because here there is no occupancy. So I'll calculate for this u3, and with the help of uh, v4 and u3 c20, so u3 will become 20. Here also u4 will become 1, here 0, so u4 will become 0. We can calculate with the help of this occupied cell, that the value of v1, so v1 will be 0, c equal to u plus v, so u1 is 10, so the value of v1 will become 0. With the help of this cell you can calculate the value of v2, so the v2 will become minus 12. See here 8 equal to u3 20 plus v2, so 20 will come in the left side, so 8 minus 20 will become minus 12. With the help of this cell we can calculate the value of u2, and the value of u2, see here 30 equal to here minus 12, so 30 minus 12 you will find here 42, and here with the help of this cell, occupied cell, you can calculate v3, so v3 will become, see here 40 and 42, so this will become c equal to 40 equal to 4, this will become minus 2. So in this way we have calculated the row number and column number for each cells having the occupancy, and now we will proceed for calculation of opportunity cost. How we calculate opportunity cost? Previously I have calculated. Once more I am just here telling you that opportunity cost symbol is this, equal to C minus under bracket U plus V. So for each unoccupied cell we will go for calculation of opportunity cost, and we will see whether the all opportunity costs are positive. If all opportunity costs will be positive, the solution will be optimal. So for example, we will calculate for this. C is 30, and here U is U1. We will take this one, and this column number, this column number means we will take value of V2 and U1 for calculation of opportunity cost for this. So here 30 minus, here U1 is 10 minus, here sorry minus 12, it is already minus. So here the value 30 minus 10 minus 12, that is minus 2. So this will become 30 minus minus 2, 32. In this way, this we will follow to calculate the opportunity cost, and here the opportunity cost is 32. For this cell, opportunity cost will become 42 with the same method. Now we will go for calculation of this, and opportunity cost for this will become 28, 18. For this opportunity cost will become 18. Then here opportunity cost 20, 52. For this cell it is 0. For this cell 12. For this cell 2. So like this, here what we are finding, that opportunity cost of not a single unoccupied cell is negative, means that all the opportunity costs are positive. So the solution is optimal. This would be the allocation. Now we will summarize the answer. Here factory, then warehouse, then units from the final table, and we will find here total cost. What would be the total? So F1 to W1, how many units? 5 units, and total cost we will do 5 into 10, 5 into 10 equal to, then F1 to W4, 2 unit, and here 2 into 10, that is cost is 10, this is 50, this is 20, and then F22 F22 W2 2 2 unit, and this is 2 into 30, total 60. Again F22 W3 and unit 7 into 40, 280. Again F32 W2, and here unit is 6 unit, 6 into 8, 48. Again F3 to W4, unit 12, so 12 into the cost is given. I am referring last matrix 20 to 40, and again F4, that is dummy cell, dummy row, F4 to W4, that is 1 unit, so 1 into 0 cost equal to 0. We will make total of this gives 698. So this is the optimal solution. In this way we use Modi method to solve transportation problem.